Hello friends, welcome to our digital. So in our previous session we discussed about big data Hadoop 1x architecture. Today I'm going to explain about 2x architecture. Before starting 2x architecture, few things we want to understand about 1x related. So here in this slide we are able to see five important nodes. That is, first one name node, second one secondary name node, and third one job tracker, and fourth one data node, and fifth one task tracker. So whenever Hadoop admin team want to install Hadoop software on top of Linux operating system, compulsory they have to set up these five nodes. Okay, so here node means you can assume as a system or you can assume as a hard disk. So Hadoop perspective, always instead of calling system or a hard disk, we have to call here a node. Node means one system. So here all these five nodes, they have to configure Hadoop admin system. Okay. So who has to configure all these five nodes means Hadoop admin team has to configure all these five nodes in a cluster. So we have one concept here. What is a single node cluster and what is a multi-node cluster? So single node cluster means same mission if it will work like name node, secondary name node, job tracker, data node and a task tracker. So all these five processors are running in same mission means that is called a single node cluster. What is a multi-node cluster? Multi-node means each processor will run on different missions, like a name node separate mission, secondary name node separate mission, job tracker also separate mission. So each and every processor running on different nodes means that is called a multi-node cluster or fully distribution mode. So generally in Hadoop interviews, uh, they will ask like what is the difference between a single node cluster and a fully distribution mode. Okay, so we have to explain single node means all the five processors running in same mission means that is called a single node cluster. If all the processors are running on different missions, that is called a multi-node cluster or fully distribution mode. In all the real-time projects, generally they will use a multi-node cluster. But in a personal laptops or most of the training institutes or organization means educational institutes, they will use a single node cluster. So here in Hadoop 1x architecture, we discussed about block size, right? Okay, so 1x default block size 64 MB. This we discussed, okay, but we can increase up to 128 MB. Okay, so by default with the Hadoop software, it will come like 64 MB, but we can increase up to 128 MB. So even you can increase up to 90 MB also, but the max limit 128 MB only. And coming to 2x, Hadoop 2x, default block size 128 MB, but you can increase up to 1 GB. Okay, so this also sometimes in interviews they will ask, okay, what is the uh, block size in 1x and what is the block size in 2x and up to what level we can increase the block size. Okay, so this is about Hadoop 1x and 2x block size, and based on block size your split also Hadoop job tracker will take care, right? If block size is 128 MB means each split also your Hadoop framework will split into 128 MB only. And about the replication factor, we already discussed, right? Okay, so each block it will each copy of the data it will replicate into three different blocks. Okay, and about name node, we already discussed that it will store only metadata. Okay, but without consulting the name node, it is not possible to access the data files in HDFS. Okay, so if you want to access your data, compulsory first you have to approach only name node because name node knows that where your data stored. So for reading purpose or writing purpose or delete purpose also, always each and every user has to consult only name node. Okay, so here five important nodes. This we already discussed. A name node only to store your metadata, and a secondary name node that is only for backup purpose. Whatever data is there in name node, same metadata always it will keep a backup in secondary name node. And data node, your actual data files it will store inside data nodes. And coming to job tracker, so processing capabilities only job tracker having. And here all these five nodes they divided into two categories. Okay, so master nodes and slave nodes. Master nodes, name node, secondary name node, job tracker. These three will call as master nodes. And task tracker and data node will call as slave nodes. And in this diagram, client means you can assume user or I am the user or I am the client. So I want to process some data or I want to store my data. So processing capabilities, so who is having means only MapReduce having processing capabilities. And the storage capabilities, which component having means only HDFS component having process storage capabilities. So under MapReduce, job tracker will take care about the processing capabilities and storage or space allocation name node and a secondary name node will take care. So all these three nodes will call as master nodes and a n number of data nodes and the task trackers will call as slaves nodes. So here if we see each and every job tracker and task tracker sending heartbeat signals, right? And even data node to name node also heartbeat signals going on. So heartbeat signals we already discussed. Okay, so whatever tasks job tracker will assign to task tracker, so that work task tracker has to complete and again it has to give progress report back to the job tracker. And here also each and every data node has to send a block level report to a name node. And about the name node, so first point is name node is a master node. And the second point, name node will call as a manager for a Hadoop architecture. And the third point, name node always it holds only metadata. Metadata means file name, file size, block ID, block size, file location, and the username, timestamp, date. So these all will come under metadata. And next point, for name node we need more RAM is required, right? Because it has to give fast response to each and every user or each and every data node. That's why more RAM is required for name node. Also in 1x we discussed, right? Name node is the single point of failure for the Hadoop cluster. We have to wait until it is up. So we don't know when Hadoop admin team will make it up. Okay, so this is one major drawback in Hadoop 1x architecture. So in maybe later slides we'll discuss about the 2x architecture. At the time we'll see whether this major drawback is resolved or not. Also here I have two data files. So foo.txt, bar.txt. So foo.txt name node assigned 3 blocks, and bar.txt name node assigned 2 blocks. So here I have 3 data nodes left side, another 3 data nodes right side. So you can assume this is a first rack. Rack 1 contains 3 data nodes, and the rack 2 contains another 3 data nodes. So 001 block, how many places it is replicated? So data node 1 copy is there, and here also 001, that means second copy is there, and the third copy it is there in a different rack and a different data node. So why third copy it is placed into different machine and a different rack means, if that copy also if we keep in the same rack, if this rack goes down means all 3 copies of the data it will impact. So that time it will be problem to access the data. That's why Hadoop framework always third copy of the data it will place in a different rack or different node or different data center or different location related server. Coming to secondary name node. So we know about secondary name node, it is just a backup purpose. So whatever metadata, latest metadata always available in a name node. Same metadata, this fs image every 30 minutes it will send to secondary name node, so that the secondary name node will keep a backup. And coming to job tracker. So job tracker first point will call as master node, and who is having a processing capabilities means only job tracker having processing capabilities, that is called second point. And third point, always job tracker will coordinate with the task tracker. Okay, so what are the tasks assigned to task tracker, those tasks completed or not, so that tracking also your job tracker will take care. And about data node we already discussed. Okay, so data node only your actual data it will store, and uh, data node always it will send a block level report to name node. So like what other blocks is full and what other blocks space is available, that information via heartbeat signals it will send to name node, so that the name node will update metadata information inside the name node. And the task tracker, we know task tracker generally will call as a slave node. Okay, so this slave node whatever work a job tracker will assign, same work it will execute, and it will give progress report back to the job tracker. Like if it is success message, if it is failure message, if it is still in progress means it will send like 20% progress or 30% progress, like that. Coming to Hadoop 2x architecture, in 1x architecture we have 4 5 drawbacks. Those 4 5 drawbacks in 2x there is allowed. So remaining all architecture everything same only. Okay, so first point here, if we see name node. Okay, so name node, Hadoop 1x we have only one name node, but in 2x we have multiple name nodes. So they introduced a multiple name nodes concept, but max number of name nodes you can keep in a cluster only 4 name nodes. Okay, but in real time projects they are using only 2 name nodes instead of 4 name nodes. They introduced multiple name nodes. Okay, so name node 1 and name node 2, name node 3 and name node 4. But here if we observe, all the data nodes are sending heartbeat signals to the name nodes. But who will give response back to the data nodes, or who will give response back to the users? Okay, that means Out of four name nodes, one name node will be in active mode. Remaining all three will be in standby mode. So the active mode name node has to take care about responses. Okay. So now this active name node will take care everything. In case if this active name node goes down means immediately your name node 2 will up. So this will it will move from standby mode to active mode, and this will work like your first name node. So again, if second name node goes down, third. If third goes down, fourth. If fourth goes down, obviously your secondary name node available. So generally in real time, if one name node goes down means Hadoop admin team immediately resolve that issue immediately. Okay, so they will not wait till four name nodes goes down. Okay, so this is a name node issue. One major drawback in 1x architecture because single name node is there. So that issue they resolved in a 2x architecture. And coming to second point, Hadoop 1x, we have space wastage in a block, right? Instead of 64 MB file, if you keep only 30 MB file inside a block, the remaining space it will be waste, right? Okay, so in 2x, there is no space wastage. Even if you keep 30 MB file in one block, remaining space we can use for other files. You can store other files in the same block itself. So there is no space wastage in 2x architecture. Okay, so that is second point. So that issue also resolved in Hadoop 2x architecture. And coming to third point, Hadoop 1x for one cluster, it is allowing only 4,000 nodes. Okay, in server room, you can keep 4,000 nodes. So for one cluster, it will allow to configure only 4,000 nodes, but not more than 4,000 nodes. But in a 2x architecture, you can configure for one cluster n number of nodes, but they tested with only 10,000 nodes, but Apache software company is telling that it is supporting a number of nodes. Okay, so that is a third point. And coming to a fourth point, okay, so fourth point, we have in the 1x architecture we have task tracker, right? Each and every data node contains one tt. Tt means a task tracker, but in 2x that tt they renamed as nm. nm means a node manager. So task tracker they renamed as a node manager. So each and every data node contains here a node manager. Coming to fifth point, Hadoop 1x we have job tracker, right? So that job tracker here they renamed as a resource manager. Okay, so except these five changes, there is no difference between 1x and 2x. Okay, so when they released a Hadoop 2x in market, after that onwards only most of the MNC companies they started using a big data Hadoop, because when initially they released 1x, there are many issues and drawbacks in 1x. That's why most of the companies they haven't used big data Hadoop. But later, after releasing 2x, most of the companies started using a big data Hadoop. And here coming to Hadoop cluster. One cluster I have a number of racks, rack 1, rack 2, rack 3, rack 4, rack 5 like that. So rack 1, one name node remaining all data nodes. Rack 2, job tracker remaining all data nodes. And rack 3, secondary name node remaining all data nodes. And here remaining all the racks only data nodes. But here why they kept name node, job tracker, secondary name node on different racks? Why means these three nodes generally will call as master nodes. So if you keep all the master nodes in the same rack, if the track goes down means it will impact for all the master nodes, right? So that's why all the master nodes in real time Hadoop admin team, they will configure in a different racks and different missions. So that is the meaning of this slide. In real time projects, they will use only two name nodes. So instead of four name nodes, they will use only two name nodes. One is active name node, second one is standby name node. But all the data nodes will send a latest metadata via heartbeat signals to the all the name nodes. Okay, so if this name node goes down means immediately this standby name node will move to active mode and it will work like your first name node. Okay, here I have one server name node, secondary name node. Rack 1 contains three data nodes and rack 2 contains only two data nodes. So I have a data file here. You can assume this data file size is 94 MB. You can use a Hadoop command or you can write a Java program or you can write a SQL query. Using anything, if you try to store your data, it will split into two copies, right? In one X 64 MB first split and remaining second split. So 64 MB, how many places it is replicated? Data node 1, data node 2, and the third copy it is placed different rack and inside data node 4. Even if you see a blue color related two copies in rack 2, but third copy in a different rack. Coming to heartbeat signal, we discussed, right? Every 3 seconds, each and every task tracker has to send heartbeat signals to the job tracker. And the same time, data nodes also it has to send heartbeat signals to the name node. But task tracker to job tracker only progress report. But data node to name node block level report it will send. And now you can assume I have 5 nodes, but I have to configure like I have 5 systems. Which system has to work like name node and which system has to work like secondary name node. So, so that kind of configuration Hadoop admin team will take care. Okay, so by default with the Hadoop software, we'll get these XML files. So master.xml file. If you configure a specific mission related IP address inside this XML file, then that mission will work like a secondary name node. And we have one more XML that is core-site.xml. So whatever mission related IP address you will specify inside this XML, so that mission will work like a name node. And slaves.xml, inside this XML file you can configure n number of IP addresses. Those n number of missions will work like data nodes. And we have one more XML file that is mapred-site.xml file. So here if you configure a specific mission related IP address, that mission will work like your a job tracker. So basically these configurations Hadoop admin team will take care for just knowledge purpose. I am explaining here. And the types of installation we already discussed, right? About a single node cluster and a multi-node cluster. Also, your Hadoop it will support to store your data. That means write operations it will support, and read operations also it will support, and delete operations also it will support. Okay, and in HDFS model, all the configurations, if you want to do any kind of configurations, backend we have one XML file that is called hdfs-site.xml file. Inside this XML file, you can configure your block size, you can configure replication factor, and you can configure heartbeat signals and trash interval also. Block size means default 64 MB. If you want, you can increase up to 128 MB in 1x. So that here value is there, right? Here they will change. And replication also by default 3. But instead of 3, if you want to increase up to 10 or 7, you can change that value here. And also heartbeat signal by default 3, but you can increase a 4 or 5 or 6 Okay, so these configurations generally admin team will take care. Okay, but just for knowledge purpose, I am explaining here. Okay, and we have block level report. So block level report, we know each and every data node will send block level report to the name node. And a safe mode, okay, this is one important point. A safe mode, generally, for example, you have one Java server. If you start that server to up that server, it will take 1 minute or 2 minutes time, right? So same way in a Hadoop also, if you start a Hadoop server to up that Hadoop server, it will take some time, 1 minute or 2 minutes. In that 1 or 2 minutes, your Hadoop server will be in a safe mode. If server is there in safe mode means it will allow only read operations. Once a server will come out from safe mode to normal mode, then it will allow write operations, read operations, and delete. All these three operations it will allow. Okay, so here I have given some Hadoop comments to check a safe mode status. Maybe once I will start practicals, I will explain how to check server is there in safe mode or not. That I will explain later. And the next concept, types of scaling. Okay, so we have two types of scaling: horizontal scaling and vertical scaling. Horizontal scaling means, for example, you have only 10 machines. Those 10 machines almost data is full. So what you have to do, whether you have to buy new machines or you have to increase existing machines capacity. Okay, so if you add new machines into the cluster means that is a horizontal scaling. Okay, but instead of buying new machines, existing machines itself, if you increase the capacity, that is called vertical scaling.
This is about a HDFS module. Next session, I will explain about Hadoop software installation part. Thanks for watching this session. Bye bye.